Earth Systems 3209. Unit 4, the forces within Earth. Reference for this unit can be seen in the textbook in chapters 4, 15, 16, and 19, and also in the curriculum guide in Appendix A and B. Unit 4, Topic 4.3. This presentation will focus on the properties of seismic waves. Properties of seismic waves will focus on identifying the different seismic waves and describing the properties of each. When we look at seismic waves, the source of an earthquake is called the focus, and the epicenter is the point on the Earth's surface directly above the focus. Seismic waves originate at the focus and travel outward in all directions. These energy waves can be classified as, number 1, body waves. Body waves consist of primary waves and secondary waves. The second classification of seismic waves can be surface waves. Surface waves are known as love waves and Rayleigh waves. Information in the textbook can be found on pages 445 to 447. When we look at seismic waves, and in particular the body waves originate from the focus and travel in all directions through the body of the Earth. The body of the Earth is what's referred to as the Earth's interior. The first wave we look at is called the primary wave, or P wave for short. P waves move by compressing and expanding in a push-pull motion the material as it travels through it. P waves travel much like sound waves travel through air. These waves can pass through solids, liquids, and gases. They vibrate in the same direction as the wave motion. And these waves have the greatest velocity, ranging up to 6 kilometers per second, and are the first to reach seismograph stations. If we look at the diagram to the right, we can see that a compressional wave, or a P wave, is represented by a compression phase and a rarefaction phase. The compression phase is when the Earth's material is compressed together, and the rarefaction phase is when the Earth's material is relaxed and is not being compressed. This vibration direction vibrates in a back and forth motion and is in the same direction as the direction the wave travels. The second type of body wave is called the secondary wave, or S wave for short. S waves travel through material by shearing it and vibrate in the direction perpendicular to the wave motion. Because liquids and gases have no shape, these waves do not pass through liquids or gases and can only pass through solids. These waves are much like the waves on an ocean, where they move in an up and down direction as the wave energy moves in a perpendicular direction. These waves travel through Earth slower than the P wave at 3.5 kilometers per second and are the second to reach seismograph stations. If we look at the diagram to the right, we notice that there is no compression or rarefaction of the Earth's materials. Instead, the Earth's material moves in an up and down motion. So as the earthquake passes a particular point, the Earth will rise and then it will follow sink. And the direction of travel of the wave will be perpendicular to this. So materials tend to move up and down in a vertical direction as the wave energy moves in a forward direction. These are like waves on the water. If you were on the shoreline of a beach, you would notice that the waves move towards you, but the actual water itself just rises and falls in a vertical direction as the energy of the wave moves towards shoreline. And this is the same motion that secondary waves travel through the Earth. When we look at the second category of seismic waves, these are called surface waves. Surface waves differ from body waves in that they do not travel through the Earth's interior, but instead travel along paths nearly parallel to the Earth's surface. Surface waves behave like S waves in that they cause up and down and side-to-side motions as they pass, but they travel slower than S waves. When we look at surface waves, there are two types of surface waves, the first being referred to as a love wave. Love waves are surface waves that cause horizontal shearing of the ground. They move much the same way as a snake slithering across the ground. So if you look at the diagram down below, we would notice that as the wave moves forward, the direction of movement will be from left to right, like a snake slithering across the ground. Surface waves are the most destructive and they cause the most damage. And we should also note the second point, which says they vibrate in a perpendicular direction as compared to that of the wave motion. The second type of surface wave is called the Rayleigh wave. Rayleigh waves are surface waves that cause both horizontal, which is side-to-side motion, and vertical motion, which is up and down motion. Both these movements occur as the wave travels in a forward direction. So the waves vibrate in a rolling motion, which is both vertical and horizontal, and they vibrate as they travel in a forward motion. Most of the shaking felt from an earthquake is due to these waves, and these waves are the most destructive and cause the most damage. When we look at earthquake waves, instruments that are used to record earthquake waves would be called a seismograph. And the energy received at a seismograph station is recorded on a paper record called a seismogram. So both P waves and S waves are the first two to arrive at a seismograph station and be recorded on the seismogram. And later, the surface waves, both love and Rayleigh waves, arrive at a seismograph station and are recorded on a seismogram. So in summary, P waves, S waves, and surface waves are all recorded on a paper copy called a seismogram, and this is seen in the diagram below. The very first initial kick recorded by a seismogram would be the arrival of the P wave, followed by the second major kick in the seismograph station and recorded on the seismogram. This would be the arrival of the S wave. And the final movement by the seismograph marks the arrival of the surface waves, that is the love waves and the Rayleigh waves. These paper records are important when seismologists want to locate the position of an epicenter. Seismologists can determine the difference in arrival times between the P wave and the S wave, and this difference in arrival time is very important when locating the distance to the epicenter from the seismograph station. It should be noted at this point that a seismologist would require 3 seismograph readings in order to determine or pinpoint the location of the epicenter, which is located directly above the focus where the earthquake originates. When we look at seismic waves and we compare the seismic waves, we can do so by studying the information in the chart below. There are 3 different types of seismic waves. We have surface waves, which are called L waves. We have primary waves, which are called P waves. And we have secondary waves, which are called S waves. Other names by which these waves are called: a surface wave can also be called a long wave. Primary waves could be called push-pull waves, because this is the direction in which they vibrate. And secondary waves could also be called shear waves. because they move through the Earth with a shearing motion, an up and down motion. When we look at the different types of waves and the states of matter which they can pass through, surface waves can only pass through solids because they do move with a shearing motion, both vertical motion and horizontal motion. Therefore, they cannot pass through liquids and gases and only pass through solids. Primary waves move through Earth's materials with a push-pull motion and are called compression waves. Therefore, they can pass through all states of matter, such as solids, liquids, and gases. And secondary waves, again, are shear waves which have vertical motion. Therefore, they can only pass through solids. So in review, surface waves pass through solids, primary waves can pass through all states of matter, solids, liquids, and gases, and secondary waves can only pass through solids. When we compare the speed of these seismic waves, the slowest of the seismic wave would be the surface waves, followed by the second slowest wave would be called a secondary wave, which travel at approximately 3.6 kilometers per second, and the fastest wave would be the primary wave, which travels at approximately 6 kilometers per second. And these are the first to arrive at a seismic station. When we look at the particle motion, surface waves have shearing motion in a horizontal direction and vertical direction when you look at the Rayleigh wave. Primary waves have a compressional particle motion where we see the Earth's material expanding and contracting as the wave passes. And secondary waves have a shearing motion as well, where we see both horizontal and vertical motion. Horizontal with the love wave. Sorry, here we're looking at shear waves or secondary waves, so we see a shearing motion where we see primarily vertical motion as the wave passes. Let's look at some examples. Example number 1. Question reads, which description best describes P waves, which are called primary waves? Primary waves, they move in a back and forth motion, which we call a compressional wave, and they can travel through any type of material, solids, liquids, and gases. Therefore, the best answer here will be answer A. Whereas if we look at answer B, we see the same type of answer. They move in a back and forth motion, but they state they only move through solids, where we know compression waves can move through any material, solid, liquid, or gas. So the answer to the first question would be A. The second question reads, which seismic wave is the first to reach a seismic station? So the first seismic wave to reach a seismic station will be the fastest. And the fastest wave will be the primary wave. It travels at 6 kilometers per second and is the first to reach a seismic station. Let's look at example number 2. First question reads, body waves consist of, do they consist of primary waves? Yes. Do they consist of secondary waves? Yes. Do they consist of love waves? No. So therefore, they consist of both primary and secondary waves. So the answer to this question will be D. Body waves consist of both primary and secondary waves. Second question reads, which wave is the fastest and moves in a push-pull motion? So the fastest earthquake wave will be the primary wave, and it moves by compression, which generally is a push-pull motion. Your turn. Take the time and complete the following questions. The solution to this question will be on the following slide. You can pause your recording now to prepare your answer. The question reads, contrast the characteristics of primary and secondary waves. When we look at both primary and secondary waves, and we look at the properties of each, the answer should include the following. Primary waves, or P waves, are push-pull waves, which vibrate in the same direction as they move. Primary waves are the fastest earthquake wave, which moves at 6 kilometers per second, and is the first wave to arrive at the seismic station. Primary waves can pass through all states of matter, including solids, liquids, and gases. In comparison to primary waves, a secondary wave, which is also called nest wave, is a shake wave, and the particles shake in a perpendicular direction to the direction in which the wave moves. So particles shake, which cause them to vibrate in a perpendicular direction to their motion, and these are generally slower than P waves, which travel at 3.5 kilometers per second, and is the second earthquake wave to arrive at seismic stations. And these waves, because they shake, can only pass through solids and not through liquids and gases. So when we compare both primary and secondary waves, both are called body waves, but they have different characteristics which are outlined in this slide. Let's look at the points covered in this presentation. This presentation focused on the different types of seismic waves. And we generally have two categories of seismic waves, these being body waves, which consist of primary and secondary waves. And we also have surface waves, which consist of love waves and Rayleigh waves. So both types of waves are released through the energy from an earthquake.